8 honors class, we're looking at Ms. Katz's notes on chapter 12.1. This is solving quadratic equations with perfect squares. We just at the end of last chapter started solving quadratics. Basically, when we were factoring things and setting them equal to 0, what we were doing was solving them. What a solution to a quadratic equation means is when you have the parabola, whatever the solutions are the points on the x-axis where it crosses the x-axis. So the x-intercepts is another way to think of the solutions. They also call them real roots, and they also call them x-intercepts. X-intercepts, real roots, solutions, roots, zeros. These are all ways to call the solutions to quadratic equations. Basically, where the parabola crosses the x-axis. The old way, which we just learned last chapter, was you factor this as a difference of two perfect squares. You get plus and minus 7, so your answer is positive and negative 7. A negative 7 there, a positive 7 there, to get that equal to 0. We always have to set these equal to 0 in order to solve them. The new way is just without the factoring. We will still have to use a ton of factoring, but not in this particular case. We add 49 on both sides. If you take the square root of an x squared, if you take the square root of a variable when you're solving these, you have to, on the other side, put a positive negative when you take your square root of 49. Because x could be negative 7 squared equals 49, or positive 7 squared. So it's a quick way to get around this factoring and get the same answer. So we square root x squared, our answer is positive or negative 49. If you just square root a number, like if I square root 16, the square root of 16 is considered positive 4. But if I have x squared equals 16 and I square root the x squared to get x by itself, the answer is going to be positive or negative 4. If you have any questions on that, feel free to ask me. So if we were looking at something like this in solving, we would divide each side by 25. And it looks like we're going to do that. Or she GCF'd out a 25 and then found out what we needed there to make it equal 0. That would be the square root of 2. This is the new way, where it looks like she divides each side by 25, gets a squared equals 2. When you square root a squared, you have to put positive negative on the other side. And since the square root of 2 can't get broken down, it's just positive or negative square root of 2. If you had something like 4, which looks like it's a perfect square trinomial, so she factored it to m minus 5 squared. If you modified group this or whatever, you get m minus 5, which is the same as m minus 5 squared. Square roots that side, square roots to 64. Again, because there was an m in here, you have to put positive or negative by your answer, so it's positive or negative 8. Add 5 on both sides. The 5 is going to go in front of this because our final answers are going to be 5 plus 8 and also 5 minus 8, which means 13 and negative 3 are your answers. So for something like this, if you graphed something like this, and to graph it, you set it equal to 0, or you put the 64 on the other side. And if you graphed it, the places this would go through the x-axis are at 13 and at negative 3. Here's a starred problem we'll work through. This is another one that we'll solve with perfect squares. We're going to add 4 on both sides to get 36 here. We divide 6 on both sides, so we're 6 here and x plus 9 squared. We're going to square root both sides, and again, because we square rooted something with a variable in it, we're going to have to put a positive or negative on the other side. Root 6 cannot be broken down, so we have to subtract 9 on both sides, and we end up with negative 9 plus square root of 6 and negative 9 negative 9 minus root of 6. Those are our two solutions for this one, which means at negative 9 plus root 6, it's going to cross the x-axis, and also at negative 9 minus root 6, it's going to cross the x-axis. If you know the solutions of a quadratic equation, it's very easy to find its axis of symmetry, because the axis of symmetry is always going to be right in between the two solutions. Because these things are symmetric, like something like this. If it's symmetric, if we find the two, I'm going to draw another one here. Actually, I'm going to start a new one. If we have this parabola, and say it crosses x at 2 and 6, we know the axis of symmetry has to be at 4, because it has to be the same distance from this as it is from this. So if you know the roots or the solutions of a quadratic, you can find the axis of symmetry just literally by taking the average. You do 2 plus 6 divided by 2. So you're taking the average of 2 and 6. It's going to be 8 over 2, which equals 4. So the axis of symmetry is x equals 4. This is another way to get the axis of symmetry for a parabola. That's lesson 12.1 though. Miss Katz's notes for solving quadratic equations with perfect squares.